Welcome back, everyone, to the Deep Dive. Today we're going to be tackling a story that really is quite fascinating. And it all started with something as humble as a layer of clay.
Oh, wow. A layer of clay.
Yeah. One of our listeners actually flagged this in some material they shared with us. And we were like, huh, this is interesting. Let's dig into this a little bit deeper.
Okay, yeah.
What unfolded from this seemingly ordinary substance, though, is nothing short of a radical rewrite of the history of life on Earth. It links this charming Italian hill town to a planet-altering catastrophe and the disappearance of creatures like ammonites.
Ammonites, fascinating.
Yeah.
I'm excited to hear more about this.
Yeah, so the material that you shared really paints a pretty incredible picture.
It does, it does. And it all begins in a place that on the surface seems completely removed from these dramatic events.
Yeah, exactly.
Yeah.
So picture this. Gubbio, Italy. Okay?
Okay.
This is a beautiful, timeless little town nestled in the Apennine foothills. It's not too far from Rome. And the streets are so narrow, it feels like they were designed for horses and carts, not cars.
Right.
And the ancient stone piazzas just breathe history.
Mm-hmm.
Like if you were there in the quieter months, you'd almost feel like you stepped back centuries.
I can only imagine.
But this seemingly peaceful place holds a key lesson. Okay, even the most stable environments can be subject to sudden catastrophic change. And this is a story that's etched in the rocks nearby.
So the landscape itself tells the story.
It does. It does.
Yeah.
And just a short distance from Gubbio is the Gola d'Obotazione. It's this dramatic gorge where the walls of limestone are striped diagonally.
Okay.
These aren't just random patterns, though. Each stripe represents layers of sediment that were laid down over these vast stretches of time in these ancient seas.
Wow.
So walking through that gorge is truly like walking through Earth's history. Like each layer tells a story.
Wow, that sounds pretty amazing.
Yeah, it's pretty cool. And it was there in the late 1970s that a geologist named Walter Alvarez, he made this accidental discovery. He wasn't even looking for evidence of world-ending events. He was actually studying the formation of the Apennine Mountains.
Right.
But he stumbled upon a thin, unassuming layer of clay.
Okay.
And this tiny band of clay held the initial clues to a massive asteroid impact that ended the Cretaceous period. It caused what was probably the worst day in the history of life on this planet,
The worst.
wiping out roughly 3/4 of all species.
Wow. That's a bad day.
A bad day, yeah.
What's fascinating to me here is that something so seemingly insignificant, a thin band of clay could unlock the secrets of such a monumental event. I was reading in the source material that even mentions how this clay layer is exposed in the gorge, and it's been touched by countless curious fingers over the years, much like they even compare it to the worn toes of the bronze St. Peter in Rome.
Really?
It's fascinating. It really speaks to that fundamental human drive to understand our past.
That's so cool. Yeah, and Walter Alvarez, the geologist who found this pivotal layer, he came from a family that was deeply rooted in science. His great-grandfather and grandfather were both physicians.
Oh, wow.
And his father, Louis, was a Nobel Prize-winning physicist at Berkeley.
Okay. Wow, so science is in the family.
Big time.
Yeah.
But interestingly enough, it was actually his mother who first sparked his interest in geology during walks in the Berkeley Hills.
Oh, interesting.
Yeah. And he went on to have a really interesting career. He worked in the oil industry in Libya.
Wow.
Can you imagine being there during Gaddafi's rise to power?
Oh my goodness. That's quite a time and place.
Wild time, wild place. Yeah, and then later he secured a research position at the Lamont Doherty Earth Observatory,
Okay.
right as the plate tectonics revolution was taking hold.
So he's there at a really interesting time
Yeah,
for geology.
yeah. He had a solid understanding of geological principles by that point.
Right.
Yeah. And, his initial work in Gubbio was focused on understanding the formation of the Italian peninsula.
Okay.
And he was using this reddish limestone that was common in the region called scaglio rosso.
Okay.
And it was through this research that he collaborated with Isabella Promoli Silva, an expert on foraminifera.
Foraminifera.
Yeah,
It's a mouthful.
it is.
I'm glad you're going to explain what those are because I think a lot of people listening probably don't know.
Yeah. Okay, let's unpack foraminifera, or forams for
Yeah.
short.
Yeah.
Okay, you might never have heard of them, but these tiny marine creatures are incredibly important to geologists. They have distinctive shell shapes that vary from species to species. Some of them look like tiny coiled snails, others look like little stars you'd have to look under a microscope.
Oh, wow.
But they were so widespread and their fossils are so abundant that they actually serve as fantastic index fossils.
So using these forms they can understand, geologists can understand the age of rocks.
Yeah, an expert like Silva can actually determine the age of a rock layer just by identifying the types of forms that are present.
Wow.
So these tiny creatures, seemingly insignificant, right?
Right.
They became crucial witnesses to this planet-altering event. And their sudden disappearance signaled this global crisis.
Interesting.
Yeah.
And as they were examining the layers in the Gola d'Albertazione, Silva pointed out something truly strange to Alvarez. In the limestone layers from the late Cretaceous period, they found a rich and diverse assemblage of relatively large forms.
Okay.
But then right at the boundary with that thin clay layer, all the large forms disappeared completely. The clay layer itself was barren. And then above the clay, the limestone reappeared. But this time it contained only a few species of forms, and all of them were tiny and completely different from the larger ones that were found below.
Looks like a completely different population almost.
Yeah, a complete turnover.
Wow.
It's a mystery.
Yeah. And that abrupt disappearance, it really struck Alvarez, because he had been trained in what he called hardcore uniformitarianism.
Hardcore uniformitarianism.
Hardcore uniformitarianism.
Okay, what's that?
It's this principle, going back to scientists like Charles Lyell and Charles Darwin, that changes in the earth and life occur gradually over these vast stretches of time.
Okay.
So the idea that an entire group of organisms could just vanish so suddenly, right around the same time that the non-avian dinosaurs disappeared, went against everything that he had learned.
Right, because uniformitarianism would suggest that it happened gradually.
Exactly. So he realized that he needed to figure out how much time that thin layer of clay actually represented.
Okay, so how much time is represented in that layer of clay?
Exactly.
That's when his father, Luis Alvarez, enters the story. Now, Luis Alvarez was a Nobel Prize-winning physicist, and he was known around Berkeley as the wild idea man for his incredibly innovative thinking. The source material mentions his work on everything from searching for hidden chambers in Egyptian pyramids to even analyzing evidence related to the Kennedy assassination.
Wow.
Yeah. So when Walter told him about this perplexing situation in Gubbio, Luis, with his physicist's curiosity, was immediately intrigued.
I bet.
His background as a physicist known for unconventional thinking, it allowed him to approach this geological puzzle with a fresh perspective, which led to the ingenious iridium idea.
Oh, this is good.
It's a good one.
Yeah, I like Luis.
Yeah, he seems like a really interesting guy. Okay, so Luis came up with this truly wild idea. He was going to use the element iridium to essentially time the deposition of the clay layer.
Time the deposition of the
clay layer, okay.
Okay, so iridium is incredibly rare in the Earth's crust, but it's found in relatively higher concentrations in cosmic dust that constantly falls to Earth from space.
Oh.
Okay, so Lewis reasoned that if this clay layer had taken a long time to accumulate, it would contain a measurable amount of this cosmic iridium.
Okay, I get that. So it's almost like using it as a clock.
Yeah, exactly.
Yeah.
So he contacted Frank Asaro, a colleague at Berkeley, whose lab possessed the specialized equipment needed for this precise elemental analysis.
Right.
Asaro agreed to conduct the tests, but he was reportedly quite skeptical that anything significant would be found.
Okay.
But Walter provided him with rock samples from above and below the clay layer, as well as samples of the clay itself.
All right.
And then they waited for the results.
The anticipation.
So 9 long months later, the call came in.
Right.
And the results were, well, the levels of iridium found in the clay layer samples from Gubbio were far higher than anyone expected.
Really?
Astronomically high, in fact.
Oh, wow. So like way more than just background cosmic dust.
Far exceeding what could be explained by just the normal accumulation of cosmic dust.
Okay.
Yeah. So this was a major surprise, to say the least.
Right.
To determine if this was just a localized anomaly in Italy, Walter then collected samples from other locations known to have sediments from the very end of the Cretaceous period.
Okay.
One of these was Stevens Klint in Denmark. And interestingly enough, the source describes this Danish clay layer as jet black and even smelling of dead fish.
That's not good.
Yeah.
It doesn't sound good.
No. But when those samples underwent the same analysis, they too revealed this same massive spike in iridium.
Okay. So it wasn't just a local phenomena.
No. The same also held true for samples that were collected from South Island of New Zealand.
Oh, wow. So truly a global signal.
Yeah. So Lewis apparently reacted to this news with immense excitement. One colleague even described him as acting like a shark smelling blood.
He's on to something.
Yeah, he knew he was onto something. He immediately recognized the potential for a major scientific breakthrough. And after nearly a year of intense brainstorming and analysis, the Alvarezes formulated what became known as the impact hypothesis. So their groundbreaking idea was that approximately 66 million years ago, this massive asteroid, estimated to be about 6 miles in diameter, collided with the Earth.
6 miles in diameter. That's huge.
Huge, yeah. And this colossal impact would have released an unimaginable amount of energy, equivalent to hundreds of millions of megatons of TNT.
That's hard to even fathom.
It's mind-blowing. The force of the impact would vaporize the asteroid and a significant portion of the Earth's crust, sending vast amounts of debris, including that telltale iridium, high into the atmosphere and distributing it globally.
Okay.
And this catastrophic event would plunge the Earth into prolonged darkness, cause drastic drops in temperature, and ultimately trigger that global mass extinction.
Wow. Okay, so they have their hypothesis.
Yeah, they have a hypothesis.
What happens next?
They meticulously documented their findings from Gubbio and Stevens-Clint. They
What?
clearly laid out their impact hypothesis and submitted their work to the prestigious journal Science.
Bold move.
Yeah. So when their paper, titled Extraterrestrial Cause for the Cretaceous Tertiary Extinction, was published in June of 1980, it ignited a firestorm of debate,
Oh, I bet.
not just within the field of paleontology, but across various scientific disciplines and in the popular media.
Makes sense.
It was a huge deal. Suddenly, everyone was talking about the asteroid that had supposedly wiped out the dinosaurs.
Yeah, because up until that point, I think the common understanding was that the dinosaurs died out gradually.
Yeah,
So this is big news.
huge news.
Yeah.
But within the established paleontological community, the initial reaction was largely one of skepticism
Oh, really?
and even outright hostility. Many paleontologists were deeply resistant to this idea.
Okay, I'm interested to hear why.
So some argue that the apparent suddenness of the mass extinction was merely an artifact of statistical analysis or a flawed understanding of fossil classification. Others felt that the Alvarez, coming from outside the field of paleontology, lacked the necessary expertise to even interpret the fossil record.
So they weren't even really considered paleontologists.
No. And there were even dismissive remarks made about unseen bolides dropping into an unseen sea.
Unseen bolides.
Unseen bolides.
What a diss.
Yeah. The New York Times editorial board surprisingly even weighed in,
Really?
suggesting that perhaps astronomers should stick to astrology when it came to explaining earthly events.
Wow. Okay, so they weren't having it.
No, they were not. To really understand this strong resistance, though, you have to consider the historical context of geology, particularly the long-held influence of Charles Lyell and the principle of uniformitarianism.
Okay.
So for a considerable period, the prevailing scientific view was that Earth's history was characterized by these slow, gradual, and continuous changes, driven by processes we can observe today.
Okay.
And mass extinctions, which clearly stood out as abrupt events in the fossil record, posed a significant challenge to this fundamental idea. But influential figures, like John Phillips, actually use these very extinctions to define the major eras of geological time: the Paleozoic, the Mesozoic, and the Cenozoic.
Mm.
And events like the end Permian and end Cretaceous extinctions, they mark these major transitions.
All right.
Lyell himself was certainly aware of the significant changes in the fossil record at the end of the Cretaceous period.
Oh.
He noted a distinct chasm between the types of plants and animals found at late Cretaceous rocks and those in the early Tertiary, now called the Paleogene period.
Okay.
And creatures like belemnites, ammonites, and rudous bivalves, which were abundant in the late Cretaceous, just simply disappeared from the record.
Right.
But rather than attributing this to a sudden catastrophic event, Lyell interpreted it as a long missing interval of time in the fossil record, like a period for which we simply hadn't found any rocks.
Okay, so they hadn't found the evidence.
Yeah, they just hadn't found it yet. And Charles Darwin echoed this perspective in his seminal work on the origin of species. He acknowledged the seemingly wonderfully sudden disappearance of ammonites, but attributed it to what he called the imperfectly kept history of the fossil record.
Right.
So he firmly believed that if we had a more complete record of past life, we would see a much slower, more gradual process of extinction, dismissing this notion of large-scale cataclysms.
So he was really in the gradualist camp.
Yes, very much so. So for many decades, this uniformitarian view held considerable sway within the scientific community.
Okay.
But as more and more fossils were unearthed, it became increasingly difficult to explain away those dramatic end Cretaceous extinctions as simply gaps in the fossil record. The changes observed were just too widespread and too abrupt. But yet, despite this growing body of evidence, the scientific community still largely resisted any explanations that invoked these sudden, catastrophic events.
Huh.
Even in the very same year that the Alvarez paper was published, a highly influential paleontologist named George Gaylord Simpson, he described the end Cretaceous turnover of life as part of a long and essentially continuous process.
Oh, wow.
So you can see how deeply ingrained this idea was.
Right.
But the evidence supporting the impact hypothesis just continued to accumulate. One of the first significant pieces of independent confirmation actually came in 1984 with the discovery of shocked quartz at the KT boundary in Montana.
So what quartz? What's that?
So these are tiny grains of the mineral quartz that exhibit these microscopic damage patterns caused by intense high pressure,
Okay.
the kind of pressures that are associated with nuclear explosions,
Oh, wow.
and crucially large meteorite impact craters.
Okay. So that's pretty strong evidence.
Yeah.
That something big happened.
Yeah. And then came compelling evidence of a massive tsunami triggered by the impact. Scientists discovered a distinctive layer of end Cretaceous sandstone in South Texas that appeared to have been deposited by this enormous wave. Walter Alvarez realized that such a colossal tsunami would have scoured the coastlines around the Gulf of Mexico and would have left a unique signature in the ocean sediments.
Right.
So, by examining records from thousands of sediment cores that had been drilled in the region, he found exactly that kind of fingerprint in the Gulf of Mexico.
So they're finding more and more evidence to support this impact hypothesis.
Yeah. And then came what many considered the smoking gun: the rediscovery of the Chicxulub crater beneath the Yucatan Peninsula in Mexico.
Okay.
This massive 100-mile-wide crater had actually been drilled for oil back in the 1950s, but it wasn't recognized for what it was at the time. Because it wasn't volcanic, it wasn't deemed promising for oil exploration and was largely forgotten. It wasn't until 1991 the scientists properly examined core samples from this area, and they discovered this layer of tektites.
Tektites.
These are small, glassy blobs of rock that had been melted and then rapidly cooled, precisely at the KP boundary.
Oh, wow.
This discovery was widely regarded as a major confirmation of the impact hypothesis, and it convinced many previously undecided scientists.
Wow.
The New York Times even ran the headline, "Crater Supports Extinction Theory." Sadly, Luis Alvarez had passed away by this time, and he didn't witness this widespread acceptance.
No, that's too bad.
Yeah. Walter, with a hint of dark humor, famously dubbed it the Crater of Doom, although it's now more commonly known as the Chicxulub crater, named after a nearby Mayan town.
Right.
It's really remarkable to consider that despite the strong initial resistance, the scientific community gradually shifted its opinion over the course of about 11 years. As more and more independent lines of evidence accumulated, it's a great example of the self-correcting nature of the scientific process.
Absolutely. And since the Alvarez's initial discovery, iridium layers marking the KPG boundary have been identified at dozens more locations around the globe, from Biarritz in France to the Tunisian desert, even to a seemingly unlikely location of suburban New Jersey.
New Jersey.
Yeah, New Jersey.
That's crazy.
It is crazy.
Right.
Which leads us to a particularly engaging part of this story. Our source material recounts a visit to one of these KPG boundary sites in New Jersey,
Okay.
led by Neil Landman, a paleontologist who specializes in the study of ammonites.
Okay.
Now, when you think of a significant geological site, you might imagine a dramatic cliff face or a remote, untouched landscape, right?
Yeah.
But this particular site was, well, kind of ordinary.
Really?
Yeah. It was located amidst strip malls, car dealerships, and a parking lot next to a baseball field.
That is not what I was picturing.
Yeah, you don't normally find these major scientific discoveries happening at a strip mall, but, it just goes to show that pivotal moments in Earth's history can be recorded even in the most unassuming of places.
Yeah, that's true.
Landman explained that this seemingly unglamorous location was once part of the continental shelf in a much warmer world, with significantly higher sea levels.
Oh, wow.
The iridium layer itself, while invisible to the naked eye, had been chemically confirmed in the sediments of a nearby creek bed.
Wow. Okay.
Despite the mundane surroundings, they actually found fossils. Someone on the trip unearthed a fossilized shark tooth, and then someone else discovered a fragment of an ammonite.
Cool.
It was about the size of a strawberry, and it was covered in small bumps called tubercles.
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 Right.
And landmen identified it as belonging to the species Discoscaphites iris. This connects us to the fascinating story of the ammonites themselves.
Okay, cool. I'm ready to hear about the ammonites.
Okay, so ammonites. These were an incredibly successful group of marine cephalopods that thrived in the Earth's oceans for over 300 million years.
300 million years. That's a long time.
That's a really long time. Their distinctive spiral, chambered shells are found as fossils all over the world. Even ancient peoples recognized them. The Roman writer Pliny the Elder believed they were precious stones with prophetic powers.
Really?
And in medieval India, they were revered as physical manifestations of the god Vishnu.
Wow.
So they've been around for a long time, and people have been fascinated by them for a long time.
Yeah, that's so cool.
They were distant relatives of modern-day nautiluses, building these amazing spiral shells that are divided into numerous chambers.
Okay.
The ammonite itself only occupied the last largest chamber,
Okay.
and it used the other chambers, filled with gas, for buoyancy control.
Okay.
The walls separating these chambers, called septa, were incredibly intricate, folded into these complex and beautiful patterns. These elaborate septa made their shells both lightweight and remarkably strong,
Oh, wow.
capable of withstanding immense pressure in the water column.
So how big could they get?
Well, most ammonite shells were hand-sized, but some species grew to be as large as kiddie pools.
Wow. That's amazing.
Pretty amazing.
Yeah.
So, based on the structure of their jaws, scientists believe that the closest living relatives of ammonites are actually octopuses.
Octopuses.
Octopuses, yeah.
Yeah.
However, because their soft body parts are so rarely preserved in the fossil record, much about their lives remains a subject of scientific inference. It's likely they use a form of jet propulsion to move backwards through the water.
Backwards.
Backwards.
That's so weird.
I know, right?
That's so cool.
And interestingly, while they are often artistically depicted with long, streaming tentacles,
Right.
the source mentions that paleontologist Neil Landman's more recent scientific reconstructions show them with these stubby, arm-like appendages connected by a web of tissue, giving them somewhat more of a blob-like appearance.
So not as graceful as we think.
Not quite as graceful, a little more blob-like,
Yeah.
but no less fascinating.
Yeah. Still cool. So Landman, who began studying ammonites even before the impact hypothesis gained widespread acceptance. He was initially taught the prevailing view that ammonites were already in decline during the late Cretaceous period.
Okay.
So their extinction wasn't particularly surprising.
Right.
But his own extensive research, along with the discoveries of other paleontologists, has revealed a different picture. Ammonites were actually thriving. They were exhibiting a high degree of diversity right up to the KPG boundary. He's even recently identified 2 entirely new species of ammonites from that very same unassuming creek bed in New Jersey,
Oh, wow.
including one he named Discoscaphites jerseyensis.
Nice.
Yeah,
Jersey shout-out.
Jersey shout out, that's right. So this really challenges that long-held idea that they were simply dying out gradually.
Right. So if they weren't already in decline, what exactly led to the extinction of the ammonites? That's a big question.
Yeah.
Our refined understanding of the impact event paints a truly devastating scenario. The asteroid, likely approaching at a low angle from the southeast, slammed into the Yucatan Peninsula with unimaginable force.
Okay.
And North America bore the brunt of the immediate effects, with a massive cloud of superheated vapor and ejected debris incinerating everything in its path. Imagine being a triceratops roaming in what is now Alberta. You would have had only a matter of minutes before being completely vaporized.
Oh my gosh.
The devastation didn't end with the initial impact, though. This vast amount of material that was ejected into the atmosphere, including sulfur-rich dust from the Yucatan region, spread globally. The fine dust particles in the upper atmosphere would have absorbed solar radiation, glowed with heat, and essentially broiled the surface of the planet.
Wow.
Subsequently, the sulfate aerosols blocked sunlight, leading to this prolonged impact winter that likely lasted for many months, if not years.
Whoa.
Forests around the world were decimated, evidenced by a distinct layer in the fossil record known as the fern spike.
The fern spike.
The fern spike. This is where ferns, which are rapid colonizers of disturbed environments, they suddenly became the dominant plant life.
Wow, so they just took over.
Yeah, marine ecosystems collapsed as well, leading to what scientists have termed the Strangelove Ocean. characterized by a dramatic simplification of marine life.
The strange love ocean.
Yeah. So the impact wasn't just about things dying, it fundamentally reshaped life, even causing surviving organisms to shrink in size.
Really?
A phenomenon known as the Lilliput effect.
Lilliput effect.
And this is clearly seen in the tiny forms that reappeared above the iridium layer in Gubbio.
Wow, so even the survivors were affected?
Yeah. It's pretty amazing. The sheer scale of the extinction is just staggering. On land, virtually nothing larger than a cat survived.
Wow.
All non-avian dinosaurs, including iconic creatures like hadrosaurs, tyrannosauruses, and triceratops, were completely wiped out. Bird families suffered significant losses, as did lizards, snakes, and a large proportion of mammalian families. In the oceans, along with the ammonites, the marine reptiles like plesiosaurs and mosasaurs, as well as the belemnites, also vanished.
So many.
Yeah. There were also massive losses among bivalves, brachiopods, and bryozoans. Even entire groups of marine microorganisms were nearly annihilated, including planktonic foraminifera like Abathonphelis mayorensis, the last fossils of which are found in that final Cretaceous limestone layer in Gubbio, right below the clay.
So it's like this really stark line between before and after.
It really is, yeah. This stark picture really highlights how incomplete Lyell's original interpretation of the fossil record appears to be when viewed through the lens of this overwhelming evidence.
Yeah.
It wasn't simply about missing intervals of time. It was about a sudden catastrophic event that dramatically reshaped life on Earth. And there are some concepts like preservational potential, which is the likelihood of an organism being preserved as a fossil, and the Senior-Lips effect. These help explain why seemingly sudden extinctions might appear gradual in the fossil record, due to variations in fossilization rates.
Okay, I get that.
Speaking of fossils, our source recounts a truly exciting moment during that New Jersey field trip, when Matt Garb, one of the geologists present, actually discovered a rare ammonite jaw in the creek bed.
Really?
Yeah. These fossilized jaws, also known as eptychi, are found much less frequently than the shells themselves, making it a significant find.
So they got really lucky.
Oh, you did.
Which brings us to one of the enduring mysteries surrounding this event. Why did the ammonites go completely extinct while their close cephalopod relatives, the nautiluses, managed to survive?
Yeah, that's a fascinating question. It really underscores the complex and somewhat selective nature of this mass extinction.
Yeah.
There are some compelling theories, though. Ammonite hatchlings, known as ammonitelae, were likely planktonic, meaning they lived in the upper layers of the ocean, drifting with the currents. In contrast, nautiluses, they lay relatively large eggs, and their young hatch as miniature versions of the adults that immediately descend to deeper waters. It's possible that the surface waters of the ocean were rendered too toxic or otherwise uninhabitable in the aftermath of the impact, perhaps due to acid rain or dramatic changes in ocean chemistry,
Okay.
making it impossible for those vulnerable planktonic ammonitelae to survive. While the juvenile nautiluses in the deeper, more stable waters, they found a refuge.
So they were just in the wrong place at the wrong time.
Pretty much, yeah. And it highlights the idea that survival through this cataclysm wasn't necessarily about being better adapted in a traditional Darwinian sense of gradual improvement. The conditions following the impact were unprecedented, and as paleontologist Paul Taylor astutely put it, the rules of the survival game changed abruptly and dramatically.
Yeah, I can only imagine.
Traits that had been advantageous for millions of years suddenly became critical liabilities.
Yeah.
And as Neil Landman concluded, there was likely nothing inherently wrong with the ammonites' overall life strategy. Their planktonic hatchlings were probably a very effective way to disperse and colonize new areas under normal environmental conditions. However, in the face of such an extreme and rapid global crisis, that very dispersal strategy which kept their young at the surface may have ultimately been their undoing.
Wow.
So as we bring this deep dive to a close, we've seen how a seemingly unremarkable layer of clay in this charming Italian hill town served as this first crucial clue in unraveling a monumental event in Earth's history.
Yeah, it's pretty amazing.
We journeyed from the serene beauty of Gubbio to the devastating impact of an asteroid, connecting the fields of geology, paleontology, and even astrophysics to reveal the story of a planet-altering catastrophe, and the mass extinction it triggered, forever changing the trajectory of life on our planet. We explored the initial strong resistance to this idea, deeply rooted in the long-held scientific principle of gradualism, and how our understanding of the natural world evolves as new and compelling evidence comes to light.
Yeah, that's what's so cool about science. It's constantly changing and evolving as we get new information.
Absolutely. And it all began with your curiosity, our listener. And the fascinating material that you shared with us, it's a powerful reminder of how seemingly disparate pieces of information can come together to create a truly compelling narrative, filled with those satisfying aha moments as we piece together the interconnectedness of our planet's history.
Yeah. And it just goes to show you that curiosity can lead to some pretty amazing discoveries.
Absolutely. And on that note, here's a final thought for you to consider. Given the significant role of chance and circumstance in determining which species survived and which perished during the KPG extinction, what seemingly advantageous traits in the organisms around us today might unexpectedly become vulnerabilities in a future unforeseen global crisis. This isn't about predicting some future doom, but rather about appreciating the inherent contingency of life's history and the constantly shifting rules of survival on our dynamic and ever-changing planet. Thanks for taking this deep dive with us.
Thanks, everyone.